Hello, I welcome you to this video where we want to discuss the concepts of trigonometry. So the question that we are considering is based on the ECZ Mathematics Paper 2 for 2024. So reading the question, it says in triangle PQR, PQ equal to 16.1 meters, angle QPR equal to 42 degrees, and angle PQR equal to 53 degrees. So that is as given in the diagram here. Calculate the length of QR. That is the first part. So how can we calculate the length of QR? So remember, the triangle that we have here is a non-right-angled triangle. And because of that, we can find the missing sides through the use of either the cosine rule or the sine rule, depending on what is going to suit the situation that you have in the triangle. And in this case, we are going to apply the sine rule. Why the sine rule? Because the sine rule is more convenient when these pairs can be complete. Okay, so you can have, in this case, we are saying the small letters are representing the sides, and then the angles represented by the capital letters for A and B. So in a situation where one of the four parts is missing, then you can use the sine rule. That is how it applies. So we can change this standard formula for sine rule to suit the letters that we have been given in the question. Okay? So how can we do that? We are saying we have to find QR. Okay? So let's start with QR. So QR is the side which is going to be over sine the angle which is opposite to QR. So the angle which is opposite to this is the angle at P. So over sine P equal to, then we need to come up with another pair which we can easily complete. In this case, we've been given the angle at P and the angle at Q. So we can find the angle at R by simply subtracting these two parts from 180. We are going to have the angle at this point. So we can say the sides that we are going to use to make this pair complete is PQ over sine R. So this is going to be the formula that we are going to apply, where QR and PQ are the sides, then P and R represents the angles that we are going to use. So to begin with, we are going to find the angle at R. Okay, so let's say angle R is equal to, how can we find the angle at R in this triangle that we have? So we understand that the sum of interior angles of a triangle equal to 180 degrees, meaning if we subtract the two angles from 180, we are going to have the angle at R. So that is what we are going to do. We are saying angle R is equal to 180 degrees minus 42 degrees minus 53 degrees. So angle R is equal to, from 180, when we subtract the two parts, we are going to have 85 degrees. So we know the angle at R. Having calculated this angle, then we can now go ahead and use this part of the formula that we just developed. Okay, so let's do that. We are going to substitute. QR is going to be maintained. So we are saying QR over sine P is going to be sine 42 degrees equal to PQ. Do we have the side PQ? Yes, we have. It is 16.1. So we substitute for that. We have 16.1 over sine, the angle at R is 85 degrees. Okay, so having done that, we can now go ahead and find the value of QR. So we are going to say we do the cross multiplication. So QR sine 85 degrees is equal to, so we've just multiplied this. Then the other part is going to give us 16.1 sine 42 degrees. And because our interest is QR, we can say we divide both sides by 85, sine 85 degrees. Even here we say sine 85 degrees. So that this part and that one goes, then we can have QR is equal to, so we multiply 16.1 by sine 42 degrees. Then the solution, we divide sine 85. From my end, I've calculated this is going to give me 10.8 meters. So you can also do the calculations on your calculator and see what it's going to give you. It shouldn't be different from what we have obtained here. That is for the first part where we wanted to find the length of QR. Having done that, the second part of the question says calculate the area of triangle PQR. Again, area for this triangle, which is a non-right angle triangle, is given by the formula area is equal to, so it's equal to half AB sine C, where the AB represents the sides and the angle between them is represented by the capital letter C. So in our case, we have now two sides. This side for PQ and the side for QR, which we've just calculated. The angle between these two sides is 53 degrees. So these are the two sides we are going to use. Then C, which is the angle, is going to be represented by what we have here. So let us substitute into the formula. So we are saying area is equal to half. Then where we have A and B, we are going to have this time, it's going to be 16.1. Multiplying our B is going to be 10.8. Then sine 53 degrees. Okay. So we can punch the figures on the calculator, and also this is going to give us, let me just do the calculations here. So this is going to give us 69.5 meters or square meters, because area is measured in square units. So this is going to be the area for triangle PQR. Okay, we can move our attention to the third part of the question, which is talking about the shortest distance from R to PQ. Again, we need to understand that the shortest distance is simply the perpendicular height from R to PQ, the perpendicular height. And because it is about the perpendicular height, we are going to use, okay, let me just take note. We are going to use the formula for area of a triangle, which is a right angle triangle, where we have area is equal to half base times height. Now, in our case, we've already calculated the area, which is 69.5 square meters. So we are going to substitute for area, we substitute 69.5. Then the base of this triangle, because we are saying the shortest distance from R to PQ. So this is the perpendicular height. And if this is the perpendicular height, then PQ becomes the base of this triangle. So for the base, where we have P, we are going to put 16.1. And then for the area, we use what we've already calculated. So we are going to simply find the value of H. that is going to be the perpendicular height. So let us quickly do that. So we are saying area is equal to, I'm just rewriting the formula, it's equal to 1 over 2. Our base, we are saying we are going to put PQ, the side PQ. Then we find the value of H. So for this, we already know we have 69.5 equal to 1 over 2. Okay. Multiplying the base is 16.1. Then we find we multiply by the height. So this is going to simplify to, so 69.5 is going to multiply the 2. So we have 69.5 times 2 is equal to 16.1 H. Our interest is on the perpendicular height. So if we divide on both sides by 16.1, then the height is going to be the value of this perpendicular height we are referring to. So we multiply 69.5 times 2, then the solution we divide 16.1. Okay, so from my end, we are going to obtain 8.6 meters. So this is the shortest distance, which is referred to as the perpendicular height. Shortest distance, we are saying, is going to be the perpendicular height. And through the way we've calculated here, that is how it's supposed to be done. The question goes on to say, which is now part B, solve the equation 6 sine theta equal to -3 for 180 degrees less or equal to theta less or equal to 360 degrees. That is part B. Then we are going to look at part C as we progress. So let's find the value for theta. Okay, so we have the equation is 6 sine theta is equal to -3. Okay, we can simplify this by dividing on both sides 6, and we shall remain with sine theta is equal to -1 over 2. Okay, now we've been given the condition here. Theta is supposed to be between 180 to 360 degrees. Okay, that is the condition that we have here. And in our case here, it is already been indicated that the value of theta is, the value of sine theta is negative. And we need to consider where sine is negative. Okay, so in the 4 quadrants, in the first quadrant, all are positives. In the second quadrant, only sine is positive. Then in the third and fourth quadrant, that is where sine is negative. So we are going to first of all find the value for this. We are saying theta is equal to, so we find sine inverse of -half. So this is going to give us 30 degrees. Now 30 degrees is not suiting the condition that we have here, meaning we have to go beyond 180 or between 180 to 360 degrees. So we are going to say our theta is going to be 180 degrees, then plus, when we punch on the calculator sine inverse of -half, we are going to have 30 degrees. So that 30 is what we are going to add to this. So we say theta is equal to 180 degrees plus 30 degrees. And our theta is going to be 210. That is the first part in the third quadrant. Because in the third quadrant, we understand that it goes beyond 180. That's why we've added the 180. Okay, so it goes from 0, 180. This is the third quadrant. So 180, we add the value that we've already obtained. Then going into the fourth quadrant, we are going to subtract from 360, the 30 degrees that we've obtained. So theta again is equal to 360 degrees. We subtract 30 degrees, and this is going to be 330 degrees. So that is for this part of the question in B. You just consider where is sign negative in the quadrants that we have for the first, second, third, and fourth. Okay, we can quickly move our attention to the last part of the question, which says simplify. We have the expression of x cubed minus 9x divided by x plus 3. Okay, so part C. X cubed minus 9x over x plus 3. So because we want to simplify, we can see that we've got a lot to do on the numerator part than the denominator. So we're going to do the workings for the first part, which is the numerator, and then we'll be maintaining the denominator part. So what can we do to the numerator? We can see that already x is common, so we can factor it out. So let's start by factorizing the numerator. We are going to have x, then we remain with x into x cubed. We are going to remain with x squared. Then x into negative 9x, we are going to remain with negative 9. Okay, then divided by x plus 3, we maintain the denominator. Again, we can see that what we have in the brackets here can be factorized further. So this is going to give us, we maintain the x, then this again is the same as x squared minus 3 squared over x plus 3. Okay? And we can see again what we have is what is known as the difference of two squares, meaning we can factorize it, and we are going to have x, then x minus 3 and x plus 3, close, divided by x plus 3. So the x plus 3 are going to cancel, so this part and that one goes. Then we remain with x outside, then x minus 3 as the solution, which can be simplified further to, when we multiply out x by x, we have x squared, then x times negative 3, we are going to have 3x. So this is going to be the solution to the last part of the question. So that is how we are supposed to find the solutions to the questions that we have been given in this question from the ECZ Mathematics for 2024. I hope you find this video to be helpful, and I'll see you in the next one. Thank you.